Got it. Hello, assalamu alaikum. Today we will discuss about the latest Codeforces Round 1895 choose all four problems A, B, C1 and C2. Mainly C has two version, easy version and hard version. So all this four problem or three problem we will discuss in this video editorial. So as I try to discuss three problem in one video, so I do not want to take more time to discuss about the problem statement. So my humble request for everyone that you at the first time read the problem statement from your own duty. So I try to just show the graphic view of this problem. So what is our first problem? A, Dalton the teacher. What is the main graphic view of this problem? Here Dalton is a person who is a teacher of a class. In his class he has total n number of chairs. They are number from 1 to n. Their number from 1 to n, and in his class he also has n number of students. The students ID is P1, P2, P3 and so on. P3 and so on. The more important object at here is a student become happy. A student become happy when the student seated in a chair, that chair number and his ID number is not equal. As P1 student take the 8th seat, first seat, P2 student take the second seat, P3 student take the third seat, as the same way P8 student take the 8th seat. So a student become happy if his ID num is not equal to the number of chair. So this is the main object or main key point of this problem. What is the Dalton want? Dalton wants to make all his student happy. So to make his student happy, what the step he can do? He can choose two distinct student I and J. He can choose two distinct student I and J and shift their chair, so that both student become happy. This is the main operation of our problem. This operation he can perform as more time as he want. But what is the main requirement of our problem statement? The main requirement of our problem is to minimize this step. Main requirement of our problem is to minimize the number of operation. So let's solve some example. This will be more better option to understand the problem statement. So I take the first problem. Here is the chair number 1, here is the chair number 2, here is the student whose ID is 2, and here is the student whose ID is 1. So here any student is present who is unhappy? No, because first student whose ID nong is 2 and his chair nong is 1, so he is happy. And second student's ID nong is 1 and his chair nong is 2, so he is also happy. So here he does not need to make any extra operation to make them happy. So as we want to minimize the operation, so our operation nong is 0. Here already every student is happy. So let's solve another example, 1, 2 and 3. What is the chair nong at here? 1, 2 and 3. This is the chair nong. What is the student ID at here? 1, 2 and 3. If we try to see this graphic view, here every student is unhappy. Why? Because every student's student ID and chair nong is same. So Dalton have to make some operation to make all of them happy. If he choose 1 and 2 nong student and swap their chair, what will be the situation? This is our first operation, 2, 1 and 3. So both 1 and 2 student become happy after this operation. Now all of the students is happy? No, number 3 student is unhappy. Why? Because his ID nong and his chair nong is same. So he have to perform another operation. He have to perform his second operation. In second operation he can choose these 2 student. If he choose 2 students, so the chair distribution will be 2, 3 and 1, and student distribution will be 1, 2 and 3. If we try to observe from the situation, here every student is happy. So how many operation he need to perform at here? 2. This is the minimum number of operation he need to perform to make all of the student happy. This is the main requirement of our problem. So we solve another example, and next we shifted to discuss the solving approach of this problem. 1, 2, 5, 4 and 3. 1, 2, 5, 4 and 3. 1, 2, 5, 4 and 3. What is the chair nong? Chair nong is 1, 2, 3, 4 and 5. Now at the first time count that how many student is unhappy at here. 1, 2, 4. Total 3 student is unhappy at here. So in first operation, what can we do? We can choose these 2 student and shift their chair. So 2, 1, 3, 4 and 5. So student nong is 1, 2, 5, 4 and 3. That's very good. Now how many student is unhappy at here? This 4 students. So we choose a happy student to shift their chair to make the number 4 student happy. So we choose this student, so we swap between themselves, and the situation will be 2, 1, 3, 5, 4. So student distribution is 1, 2, 5, 4 and 3. Now all the student is happy at here. So how many operation we need to perform at here? 2 operation. This is the main requirement of the problem. I guess that what is the main requirement of the problem, or what is the main graphics view of this problem, this you can all understand. Now come to discuss about the solving approach. If we see these 3 example we solve at here, what in one operation, what step we do to minimize the operation, number of operation? We choose at a time 2 unhappy students. We choose at a time 2 unhappy student to minimize the operation. Why we choose 2 unhappy student at a time to minimize this operation? Because in that case, in one step we can make 2 unhappy student to happy student, 2 unhappy student to happy student. So that's why we choose 2 unhappy student at a time or as a pair to make them unhappy to happy. So in every operation, how many element we decrease, how many unhappy number we will decrease? Number of 2. So our total unhappy decretion is our unhappy decretion ratio is by 2. Now here we have another observation or another side case. Let's assume that this 4 student is unhappy. So if we choose this one and this one, we need 2 operation. We need 2 operation because total 4 number of student is unhappy. Every operation we will decrease 2 student from this list. So total number of operation needs 2. But if we have here, if we have total 5 unhappy student, what we have to do? Here we also have to choose an happy student and shift his chair with this unhappy student to make that unhappy student to happy student. So here an extra operation we need to perform at here. So what the step we can take to resolve this problem? We have to count the total unhappy number of student at the first time. We will count total unhappy number of student at the first time at 1 by 2. Why we add 1 at here? For this extra number of student, or for the odd number of unhappy student. Now this will handle for the even number of cases. Yes, because we count floor value at here. We count floor value at here. Now let's assume we have 4 unhappy student. So we total number is 4. If we set these values in this formula, so 4 plus 1 is 5, 5 by 2 is 2.5, 2.5. If we take the floor value of this 2.5, this will be 2. We need 2 number of operation. This 2 will be happy after first operation, and this 2 will be happy after first operation. fine. Now let's assume that we have total 5 number of unhappy student. So how many operations we need? 1, 2 and 3. So total unhappy student is 5. 5 plus 1 is 6. 6 by 2 is 3. We need total 3 number of operation. So our generated formula is correct according to our problem. So let's shift from this code. We will at the first time we will count the total number of unhappy student. In what situation a student become unhappy? When his ID nong and his chair nong is same. So we have to give this situation or condition at here. I is equal to I plus 1. We assume a of I as the zero base indexing array. So that's why for the number of chair we have to give the condition I plus 1, because for zero base indexing array the indexing is starting from 0. So if we count if we have to start this index from the 0, so 1 2 3 this condition is not valid. In that case every value of a of I have to decrease 1. So we do not take this kind of operation, we just add 1 in this condition statement. So we count this total unhappy number of a student. So what is our total number of operation? We generate a formula unhappy plus 1 by 2. So we just put this equation at here and at the final state we print the number of operation at here. Now let's discuss about the second problem of this contest, Bay longest divisor interval. So what is the main graphic view or main wanted things of it, things at here? Main wanted things at here, they give a number to us, that is n. We have to select a range from 1 to n. We have to select a range from 1 to n, range L and R from 1 to n, so that every number from this selected interval is divisible by n. That means if the number is n and L and R, we pick a number, there is a number in this interval is x, so n percentage x will be 0. If we pick y from this list, this will be 0. If there have a number z, that also have to be 0. That means we have to choose such kind of interval, that we have to choose such kind of interval where every number is divisible by n. That is our main requirement of this problem. Now what is the most confusing part of this problem? This is the range or constraint. The number of range of the n constant is 10 to the power 18. So many one think that we have to use some binary search operation or some other mathematical formula to generate this to solve this problem, but we can solve this problem using this binary search algorithm, or if any some other mathematical formula we have, we can use them to solve this problem. But we do not need to take some more operation, some more step to solve this problem. Why? Because we have to know a simple discrete mathematics formula. What is that formula? If we have a number of n and we have to pick a number of interval L and R such that all the number in that interval is divisible by n, then in that case the number of range will always started with 1. Number of range always started with 1. So what we can say that if the value of n range is 10 to the power 18, we do not need to consider whatever the number is. Our longest interval will be started with 1. Then if 2 is divisible by 10 to the power 18, continue by n, we assume n. So if 3 we can continue, if 4 we can continue. How many times this range or interval will go or alive? This interval will be alive. This range or interval is not alive too much time, like 10 to the power 5, 10 to the power 6 or 10 to the power 7 or 8, so that TLE will become at here. So we can use brute force solution at here. Why we cannot select another range or another interval to choose this number? Because every number has even or odd condition. The situation can be break in this case, or this situation can be break for some, this situation can be break some prime number, this situation can be break for some prime number, or any number that cannot be represent as like as this way, as like as this way. So if I into I plus 1, if I plus 3, I plus 2, if I plus 2 have to be divisible by I, so and I plus 3, so on. So in that case the range will not be selected from any mid part of the total range. So our number will always started with 1, and we can run a brute force solution to pick how long the range is. So if we choose an element 40, so what if we take the range from the L is equal to 1, what will be the situation? 1 2, because 3 is not divided by 4. Here the answer give is, here what the range length is 2. If any range mid-side part of 1 to 40 that is greater than or is equal greater than 2 can be equal to but not greater than 2. If we pick 8, what is divisible by 40? How can we represent that number? 5 into 8. So 5 into 8. But if we, any situation or any formula we can represent it by 6? No. So if we start from 5, that is stop at here. If we start 8, that will be stop at here. This will be same for every number, or this condition is suitable for every number. This condition is suitable for every number. Why this range will be long? Because we have 1 at here, because every number is divisible by 1. If we pick 2, that will be range will be become 2. Here 2 is also divisible by 40. 2 is also divisible by 40. So if here also it has a number 8 and here also it has a number 5, but here the range is length is 2 because we pick 1. So from our formula, if we have a number of n and we have to pick a internal range L to R which is longest, that all element in that interval is divisible by n, then our L will be always started with 1 and our L to R distance will not be too high. So we can use brute force solution at here. If we go jump to the solution, what is our first multiply? What is our first multiple? 1. How many time we will continue this interval? While this number of multiple is multiplied by n, that number of time we will increase the number of multiply, because we have to pick a range L to R where every two distinct elements difference is 1. Every two consecutive elements difference is 1. So we have to increase the number by 1. While this number of multiple is not divisible by n, that in that case we will break that condition. Here why will decrease 1 from our multiply or answer? Because we have to choose the number of way or number of length. So if only one is divisible at here, so he will satisfy that condition and increase that number, and can be break from the next condition, so number will be 2, number became 2. As we have to pick the length of this situation, so in that for that purpose we have to decrease 1 from this chosen answer, and at the last time we will print our answer. This is our second problem solution of the last contest. Now go to the problem C. Mainly this is a one problem, but it has two version, easy version and hard version. Main difference between C1 and C2 or easy version or hard version is the number of difference or number of operation. In C1 they want total 50 operation at a time, and in C2 they want at most 31 operation to satisfy that condition. What is our condition? We have an array A of length n we have an array a of length, we have an array a of length n. We have to make this array in ascending order sorted array. We have to make this array as the ascending order sorted array. So to do this to achieve this goal, what the operation we can pick at here, we can choose two integer to index I and j from the array. We can choose to index I and j from the array and set our ai's value to a of I plus a of j. This operation we can use as many times as we want, but we do not need to minimize the number of operations. So we do not need to minimize the number of operations, but for the condition of C1, that number of operation will not cross the range of 1 to 50, and for this C2, that number of operation cannot cross the range 1 to 31. That number of operation cannot cross the range 0 to 31, 0 to 50. So this is the condition, or this is the main requirement of this problem. So let's solve some example. This will be more clear for everyone. So we pick the first example, 2 and 1. This array is sorted in increasing order? No. So we pick this element as the j, and we pick this element as the I. We pick this element as the I. So after one operation, what is the situation? 2 and 1 become 1 plus 2, 3. The array is 2, 3, which is sorted. So how many operations we need to perform? One operation we need to perform. What is the indexes we choose for every time? We will choose the indexes 2 and 1. We will choose the indexes 2 and 1. And this is the main requirement of our problem. This is the main requirement of our problem. We have to print at the first line the total number of operation. Next, suppose this number is k, then the next k line will print the number of indexes we will choose to make the array as our wanted situation. Make this array as our wanted situation. If we pick 2 and 1, at the first time we will pick the indexes of j, and on the next word of the line will print the indexes of I will choose. Here we will choose number 2 indexes as the I. Our situation will be print of I and j. This number will be printed as the situations of I and j. What these indexes of I in this case? First operation. In first operation we will choose the second indexes as the I and first indexes as the j. So we'll print as this way. If we see another example, 1, 2, minus 10 and 3. 1, 2, minus 10 and 3. This array is sorted? No. In what situation the array become unsorted? Between 2 and minus 10. So to resolve this problem, we can choose I and j as the fourth index 3 times. This turn 3 to 6 from the first operation, this turn 6 to 9 from the second operation, and this turn 9 to 12 from the third number of operation. And after third number of operation, our array becomes this way. We have to perform another number of operation. We will choose this time I as a third index and j as a fourth index. So array become 2, 2 and 2, 12. So now this array is sorted. So how many operations we need to perform? We need to perform total 4 number of operation, and the I and j indices is 4 and 4, 4 and 4, and 4 and 4, 4 and 4 and 4. And to the fourth number of operation, here the I is 3 and j is 4. We have to perform total 4 number of operation, and the operation indices is 4 4 4 4 4 4 and 3 4. This is the main wanted thing of our problem. So I think the main graphic view, you can understand that what they want actually from our problem. Let's start to discuss about the solving procedure or solving approach. What will be our solving approach? If we take a brute force solution, as our internal range of n is 20 and the value of a of I is minus 20 to plus 20. So many of us can think that we can use any brute force solution at here and make every two pairs of the elements satisfy and make this arrays increasing order. But we have to think another perspective at here, that is we have the limitation of total number of operation. So we cannot use brute force solution from our own wanted object, from our own wanted thinking, from our own thinking. So we have to pick a element as a model element to do the operation as an increaser and do the operation as a decreaser, as the value of I represent both solid negative, both solid positive and 0, this kind of elements, so both increaser operation can be performed at here, both decreaser operation can be performed at here. In some situation the whole array can be negative array, in some situation whole array can be positive array. So for that perspective we have to choose a element as a model element which will do the operation as a maximum or increaser and minimum or decreaser. So we can pick the maximum element as a increaser and pick the minimum element as a decreaser. Now what is the situation, what will be solving approach of this problem? So to start to discuss about the solving approach, we try to discuss another object. If an array is already positive at here, so we pick an example 1098. If we make this array to prefix array, then array will be become sorted already. So 10, 19 and 23. So prefix solution is more suitable at here. And if the array is a negative array, as minus 2, minus 1, minus 4 and minus 5. If we make this array to the suffix array, then this array will also be sorted as this way: minus 5, minus 9 or minus 10, minus 11. As we know that minus 5 is the greater than minus 11. So we can come a decision that for the whole positive array, we can perform the prefix array to make this array sorted, and for a negative array we can make or shift this array to the suffix array. We can shift this array to a suffix array to make this array sorted. So how many operation we need to perform at here? Total n minus 1 number of operation. As the maximum value of n is 20, so here we need to perform maximum 19 operation. Number of operation. Now let's start to discuss about the problem, main problem statement. We can pick two elements as a maximum increaser or minimum increaser. Let's what is our main goal? To make this array sorted. and we perform this increaser or decreaser operation in what situation? For the positive to integer, if fi is greater than fi minus 1 is greater than fi, then we can perform an operation. Then what we need to do? We need to increase the value of fi. We need to increase the value of fi to fit with the I plus 1th index, to fit with the I plus 1th index. And for the negative array, if fi is greater than fi plus 1, what we need? We need to decrease this element. In this case, we need to increase the I element, and in this case we need to decrease the I. We need to increase the ith element, and in that case we need to increase the ith element. So we can use the model element as a increaser maximum and as a decreaser minimum. This maximum and minimum value must not be fit. This can be changes, or that means this is dynamic. This is not static. This is not static. This is dynamic. This is dynamic. Let's compare with this example. 1 to minus 10 and 5. So if we pick a model element as minus 10, so how many operations we need to perform? How many operations we need to perform? So 1 and 2, this is perfect. This, as we pick minus element as the model element, so minus 10 and 5, this is not perfect. This is not a perfect element. So for that case, in this situation, what the operation we need to increase this minus 10. We need to increase this minus 10 as 2 is greater than minus 10. So what the operation we need to perform? We need to perform the increaser operation. So if we use minus 10, as minus 10 is the minimum element, if we use minus 10 as the increaser right here, the thousand of operation cannot be make fit between the element I and I plus 1. So in that case, we need to increase the value of minus 10. So what we can do? We add 5 at here. So in first operation, minus 5. In second operation, 0. And in third operation, this will become 5, and array become 1 to 5 and 5, which is sorted. We need total 3 number of operation. But this solution is and we take another example. We take 10 minus 100 minus 150 and minus 90. If we pick the maximum element as an increaser, what is our abnormal situation at here? Our ith element is greater than a of I plus 1. So if we use the same operation or same idea at here, we need to make this minus 100 to 10, less than 10 or equal 10. So minus 19, minus 80, minus 70. Total 10 number of operation we need to perform to fit this array between I and I plus 1 element. And we need to perform total 15 operation at here, 10, 15, and we need to perform total 15 and 9. So number of operation at here is almost 10 plus 15 plus 9, almost 34. Total number of operation we need to perform, that is almost 34. That is almost 34. So if we pick a maximum or minimum element as an increaser or decreaser randomly, this cannot give suitable answer for us. Sometimes it can increase the number of range. It will increase the number of operation we can see. Our main target is not to minimize the answer, but keep the answer in this range for C1. As we discuss about the problem C of 1, So we have to pick a situation that we can fix our maximum or minimum as increaser or decreaser. What is the actual situation? If our absolute value of maximum is greater than our absolute value of minimum, then we can pick the maximum element as a increaser. Otherwise we will pick the minimum element as a decreaser. Why this condition will be suitable for this solution? Because we need to make we assume that between two indexes I and I plus 1, one element is negative and other element is positive. If our positive element can resolve the negative value, then we can pick the increaser operation. If our positive element cannot resolve the negative value as the suitable number of operation, as we have 10 as a maximum element and minus 5 as a minimum element, so we need to perform a suitable number of operation minus 5 to 5 and 10, total number of 2 operation. And if we have 10 and minus 50, then we pick the increaser operation. So we need to pick it at the first time minus 40, minus 30, minus 20, minus 10 and 0, 10. How many number of operation? 1, 2, 3, 4, 5, 6. Total 6 number of operation for make this suitable of 2 element, suitable the elements between 2 indexes. So as the same way we have to make this operation for n minus 1 time. We have to perform total 20 minus 1 or 19 into 6. 19 into 6 is 114 time, which is greater than of both 50 and 31. So we cannot pick this element. So we have to minimize that operation or minimize that case. So what is the maximum number of operation we can perform for between 2 indexes at a time? Let's assume we have 1 and we have minus 2 as the minimum element. So as we pick a increaser operation 2, 4, 8, 16 and 32, we have to perform total 1, 2, 3, 4, 5, total 5 number of operation, maximum 5 number of operation to make fit 2 elements between I and I plus 1. Fit 2 elements between I and I plus 1. So at a time we need to perform total 5 maximum number of operation, and for the rest of the n minus 1 elements, how many operation we need to perform? As we can fit this array by performing a number of operations, so we need to perform maximum 2 operation. So we need to perform total 5 plus 19 into 2, 38, total 43 number of operation at here. Total 43 number of operation, less than or is equal to 43 number of operation at here, which can be satisfy our range between 0 and 50, 0 to 50. So we can use this solution as a first increaser. So if we shift this solution or try to discuss about this the code or implementation, so we take a list as a storage of our answer. If AFI is maximum of, we at the first time we will pick the maximum element and maximum index from the array, and minimum element and minimum index of the array. If maximum and minimum is equal, that means that represent the situation all the elements of the array is equal. So no operation we need to perform at here, otherwise we need to perform the operation. Then we check that is our maximum value can resolve the minimum value as a suitable way, or between the range minus less than or is equal to 50, less than or is equal to 5. If okay, then we will choose the maximum element as increaser. If our left element is greater than our right element, then what the operation we need to perform, we have to increase our right element. So we will increase until this element is suitable according to the perspective of our left element. So every time we will collect the index, with what index we will perform this operation, our maximum index. If this maximum element is changes, we will discuss, will say that our maximum and minimum element is dynamic. This can be changed after every operation. So if this maximum element is changed, we will change our maximum element and maximum index. And if our maximum number of increaser cannot resolve the, if our maximum element cannot resolve our minimum value as minimum value to increase their value, that time we have to choose the decreaser operation. Let's take an example. If we have minus 100 and 1, then if we choose 1 as a increaser value, as though we do not have the element range between, we do not have the element range between minus 22 out 20 to 20, but to explain this situation I pick the element minus 100. So if we perform increaser operation at here, how many operations we need to perform? We need to perform total 100 number of operation at here, total 100 number of operation at here, almost 100 number of operation at here. If we perform a decreaser operation, we can make this element 1 to minus 101. We can complete this step with just one operation, with just one number of operation. So if we see that absolute value of minimum is minus 100 and absolute value of maximum is 1, so this will say that we cannot resolve the negative value with the positive value with the number of suitable operation, with the number of suitable operation. So what will be the minimum or number of operation between both of them? That will be maximum and minimums, that we can compare with the maximum and minimum value with this condition of absolute value of maximum is greater than absolute value of minimum. So we will perform the decreaser operation at here. Until a of I is greater than a of I plus 1, we will decrease the ith element and pick the indexes of operation, and as the minimum value is changes, we will pick the minimum elements and minimum index and perform the operation according to the perspective of that new minimum element or new maximum element. So at the first time we just print the total number of operation and our collected indexes, and now try to discuss about the problem C2. But this problem is acceptable for C2. We will see that we have to perform total 40 less than or equal to 43 number of operation to make this array sorted array, increasing sorted array. But what is the operation limitation at here? 31. So this solution is not suitable or not fit for C2. The solution is not fit for C2. Here we have to decrease the number of operation, or have to make more optimized solution than C1. If we try to optimize the solution C of 1, in what case, in what situation the operation number is increasing at the time of C1? In what situation or in what case the number of operation is increasing according to the perspective of C1, when we will pick two element, when we will try to fit the two element I and I plus 1, two consecutive, when we will try to make fit the elements between two consecutive index, then the operation number is increasing actually. Then the number of operation is increasing actually. Then the operation number is increasing actually. So how to optimize this solution? How to optimize this solution? At the first time, we will discuss that if we have all positive in positive array, we have to perform maximum 19 number of operation. If we have a negative array, we have to perform total 19, maximum 19 number of operation. So our main goal is to make the array, whole array, either positive array, neither negative array. So to achieve this situation, what the thing we have to do? We have to perform this increaser or decreaser operation only one time between maximum, for the maximum element or for the minimum element. We try to make the maximum element. Suppose that we try to make this array positive array, and in this case we try to make this array negative array. So in that case, we shifted this positive maximum element, as we try to shift this positive maximum element to a element x, so that it can resume or make all the negative elements, so that it can make all the negative elements of this array to the positive element. We try to shift our maximum number to a number x, so that it can make every negative element of this array to the positive element. Then our array become total positive array. Then we can perform the prefix operation, and this can take maximum 19 operation at here. What is the time and for this minimum case? We will take a number, we will shift a number, our initial minimum number, to a number y, such that it can make all the negative elements, so that it can make all the positive element of the array to the negative element. Now our array become the negative array, and we need to perform total maximum. So then we need to perform total 19 number of operation for the worst case. So we can make sure that we can decrease the number of operation between 19 plus 5. That means 23, 24. 19 is the for the prefix or suffix, and 5 is for max to min. 5 is for max to min or min to max. The number of operation we need to perform for the same element. Number of operation we need to perform for the same element. We can find a number x such that all negative number become positive number, and we will be able to find a number of y such that it can make all the positive number to the negative number. So we have to perform that operation to make this array positive array or negative array. So we need to perform total 19 plus maximum 5 plus number of solid positive element or the number of solid negative element. 19 is for prefix and suffix. 19 is for prefix and suffix. আর এটা কি, এটা হচ্ছে গিয়ে, and 5 is for max to min, and 5 is for max to min or min to max, and total number of solid positive and total number of negative element is the number of operation for make this array positive or make this array negative. Make this array positive or make this array negative. Now what is the worst case? what is the worst case at here? When we need to perform 5 operation at here, when we have to shift between 1 to -20, then we need to perform total 5 number of operation. If we have 1 and -20, if we have 1 and -20 and our range of the n is maximum, then we have total 10, 1 and total 10 number of -20. Is it recorded? Yes, 10 number of -20. So in this case, if we try to make this array whole positive, if we try to make this array, then our maximum operation need 5 times. If we try to make this array whole positive, for in this case our solid positive element is 10, our solid negative element is also 10. We need to perform total operation 19 number of time to prefix or suffix, and 5 time maximum, and have to perform total 10 number of time. So how many operation it takes from us? 19 plus 10 plus 5, that is 34. That is 34, which will violate the rules of 31, which will violate the rules of 31. So we have to find such condition so that this violation we can avoid. In the worst case, we pick that x1 is the number of total number of x1 as the total number of solid positive, and x2 as the total number of solid negative. x1 is the total number of solid positive and x2 is the total number of solid negative. What is the what is this range for the worst case? 20. And x2 as the conversion from max to min or min to max, and this is y1, this is y1, and y2 as the conversation. This range will never cross less than or 5. So if we take this summation of those value, x1 plus x2 plus y1 plus y2, this will be the range between 25. So what the object we will add for a single operation? What the object we will add for a single operation? With n minus 1. With n minus 1. N minus 1 is fixed. This we have to perform must. x1 as the number of solid positive with the number of conversation x2, and y1 with the number of conversation y2. We will pick this element either x1 or x1 plus x2 or y1 plus y2, where n minus 1 is must for both elements. So if we can decrease this number of operation x1 plus x2 and y1 plus y2, then our operation should be optimized, and this can be under this range. Why this can under this range? Because the x1 plus x2, x1 plus y1 between this range 20, this we cannot change, but this we can decrease maximum 5. This we can decrease maximum 5. So what is the maximum number of minimum or maximum element at here? We can get at here 25 plus 2, maximum 12 element at get we at here, so 19 plus, for the worst case, if this number difference is 10, if the number of solid positive integer is or solid negative integer is 10, then our next operation will be 0, because if we have total 10 number of minus 20 and total 10 number of 1, then we can pick the minus 10 as a decreaser and use the prefix operation. use the suffix operation. This will make the minus 20 as the maximum element, and it will decrease all the element between right to left. This will decrease all the element between right to left. In this case, we have 10 1 and we have 10 number of minus 20. We have 10 number of minus 20. We have total 10 number of solid positive and total 10 number of solid negative. Solid positive and total 10 number of solid negative. For the conversion, 1 to minus 20 take 5 times, but to convert minus 20 to another negative, we need to perform 0 operation. We need to perform 0 number of operation. So in that case, the value of x1 is number of solid positive is 10. The number of conversion will 0. That will be at, that is at 10 at here. So we have to perform 19 number of operation for prefix or suffix. Total 29 number of operation. Total 29 number of operation. And this condition will decrease the number of operation between the maximum total number of solid positive and solid negative between the ratio decreaser or ratio increaser. If we need to perform this situation for some other cases, our 29 to this ratio decreaser or ratio increaser does not cross the limit between +2. You can check for any situation for any case. If we have the total number of cases 19 plus 9, 9 is the total number of increaser or total number of decreaser element, then we have the number of range already, total 28 number of operation. Our all the element range between ratio between the ratio increaser or ratio decreaser is 2:3 for the maximum number of time. So it will never cross the limit 3. It will never cross the limit 3. So this will satisfy the range 31, as our ratio of ratio increaser or ratio decreaser range is 2:3 or 3:2, and our worst case, our maximum ratio is 29. When this number is solid positive or solid negative number of increase, our ratio become 2, otherwise our ratio become 3. And for some any cases, the ratio will be kept 2:3 for maximum number of time. If we have to take total 5 number of ratio, if it total come 5 number of ratio, then it will become 0. It will come if this ratio will come 4, this value will be decreasing according to that perspective, but this will never cross the limit of range 31. So if we jump to this solution, at the first time we will collect all the solid positive and solid negative number. If the solid negative number is 0, that means if this is a positive array, we will just perform a prefix operation, a prefix array. This convert this array to the prefix array, and this will take total n-1 operation. And if we discuss about the all positive and all negative number, for all positive number, this is nothing, just a prefix operation from 2 to n, I and I plus 1. I is the ith index and I minus 1 is the jth index. And for this negative array, we have, when we have to perform this suffix operation, then we will shift this array from n-1 to 1, where when this abnormal situation is created when I and I, when this the violation between the I and I plus 1th element. So jump to the main solution. When this is a negative array, we will perform the suffix operation. we will collect the maximum element and maximum index. If maximum and minimum index is equal, that means all the elements of this array is already equal, so no operation we need to perform. We'll print 0 at here. Take a copy of maximum and minimum element, as we will try to convert positive our maximum element to the x such that it can convert all the negative element of the array to the positive, and we will find or convert our minimum element or minimum negative element to a number of y, so that it can decrease all the positive element to the negative element, all the negative element, so all the positive element to negative element. So a step from min to max and min to max, min to max and max to min. At the first time we will try to find a number of range y, a number y, such that it can convert all the positive element to the negative. So increase the minimum element, decrease the minimum element, and count the number of step, and this is for the positive element. This will increase the positive element so that it can find a number x, and that x can convert all the negative element to the positive element of the array. Now if the solid positive plus a step max to min to max, why? Because solid positive number of time it have to perform their operation, and have to perform another operation to find a number of y, so that it can convert all the find a number of y, so that it can convert all the positive element to the negative element. So total this solid positive and ratio increaser will be added with n minus 1, and this solid negative, and way number of operation to find a number x, such that all the negative element of the array can turn into a positive element. So this will add with n minus 1. If solid negative is minimum, that means we have to choose minimum element, we have to make this array to the negative array. So we have to make this array to the negative array to optimize our solution. So at the first time we have to perform total number of ratio increaser, so we have to perform the total number of ratio decreaser time to find a number of y, and then have to find the total number of positive element, and perform a operation with the minimum element to turn this element to the positive to negative. Then now our array become negative array, whole negative array, and we will perform suffix operation at here. And for the case of prefix operation, we have to perform the ratio increaser. We have to perform a ratio increaser to find a number x, such that it can reduce all the negative number to the positive element, reduce number to positive element. We will, at the upper case, we will perform the ratio decreaser operation, and in this case we will perform ratio increaser operation. So we have to find all the negative number to convert it to the negative to positive, and finally now our array is whole positive element, and we will perform the prefix operation at here, and this will take n minus 1 operation, total n minus 1 number of operation. And finally, and for every step we will collect the indexes, and finally we will print the size of total number of storage, size of this dynamic storage, and finally we will print our collected indexes. So this is our total number, this is our discussion on the contest, on the latest dive to Codeforces contest. I think all of you can understand. For any query, feel free to comment. I think this will be helpful for you, and for any query or for any suggestion, you can share your feedback or opinion to me. Thank you.